Radiation is everywhere. It happens when an atom releases subatomic particles. These particles take the form of alpha, beta, and gamma. They all have different masses. Alpha is equivalent to a helium atom, beta is the mass of an electron, and gamma is equivalent to a photon.
We set up an experiment to test whether the particles' different masses affected the radiation strength with distance and shielding.
Gamma.
We individually tested different radioactive isotopes. We first placed the isotopes at different distances and recorded the counts per minute using a Geiger Mueller detector. Then we tested the isotopes at uniform distance but with different materials such as paper, aluminum, and lead in the way of the detector. We placed all our information in a chart to understand its meaning.
After our experiment, we observed our findings. We found that certain types of radiation were different in power, but distance affected all. Distance and counts per minute were interlinked and were similar with all types of radiation. Shielding and long distances caused the decrease of counts.
It was determined that alpha radiation is weak compared to beta and gamma radiation. Gamma radiation is the strongest and beta radiation is in the middle.
The results amassed to the conclusion that the abilities to penetrate depends on the mass of the radiation. Gamma radiation has no mass because it is pure energy. Beta radiation is stronger than alpha because electrons have less mass than the protons and neutrons that are in alpha radiation.